Welcome back, everyone. Today, we're exploring a massive paradigm shift that's literally altering the architecture of modern computing, generative AI. Now, if you follow tech at all, you already know the buzzword. It's everywhere. But today, we're moving past that surface-level hype. We're going to look under the hood. We're unpacking the actual underlying mechanics, the specific neural behaviors and architectural breakthroughs that have allowed machines to cross the threshold from simply analyzing data to actively synthesizing entirely new realities. We're looking at a permanent shift from deterministic output to probabilistic creation. And by the end of this explainer, you're going to understand exactly how that computational magic actually works.
Part 1. The Art of Creation. We're moving from recognizing patterns to creating them.
Okay, let's dive into this. To really grasp this shift intuitively, I want you to picture an incredibly dedicated art student locked inside a museum containing millions of paintings. Now, this student isn't just memorizing where the paintings hang on the wall. No, they're obsessively breaking down the mechanics of art itself. They're internalizing the mathematical relationships between light and shadow, the precise geometry of composition, and the exact physical behavior of different brushstrokes. After processing millions of examples, they build this deep internal intuition about how reality is visually constructed. Eventually, they don't even need to look at the old paintings anymore. They can pick up a brush and generate a masterpiece that has never existed in human history, purely by synthesizing all those internalized rules. That transition right there, from absorbing vast amounts of data to mapping the underlying rules of creation, that is the core behavior we're talking about today.
So, generative AI specifically refers to systems engineered to create brand new content, whether that's text, images, audio, or video, rather than just sorting existing data. For decades, machine learning was largely discriminative. It organized things. But recent massive computational breakthroughs, particularly the attention mechanism in transformer architectures, completely changed the game. Transformers allowed neural networks to hold on to vast amounts of context simultaneously. Instead of just analyzing a single word or pixel in isolation, the machine could suddenly understand how 1,000 different concepts related to each other all at once. That computational leap gave the system the power to not just sort data, but to step into the role of the creator, generating completely novel structures from scratch.
Section 2. Analyzing versus generating. This is the core shift.
Let's look at how this actually builds upon the traditional models we've relied on for years. For the longest time, AI was essentially a classification engine. Think of a massive banking system parsing through millions of everyday transactions just to flag the one specific transfer that might be fraudulent. It takes a complex input, processes it, and maps it to a known, distinct label. Highly valuable for sure, but entirely reactive. Generation represents the exact reverse of that pipeline. Instead of mapping complex data down to a single label, a generative model takes a simple instruction and expands it into massive complexity. It's the difference between asking an algorithm to identify a fraudulent bank transaction and commanding it to produce something entirely new, based on learned rules, like generating a fully functional synthetic financial dataset with millions of hyper-realistic yet totally fake transactions just to stress test a bank's security. It's producing something entirely new based on internalized logic.
Moving on to Section 3, the copy-paste myth. Fact versus fiction.
Of course, with an architectural leap this profound, there's a pervasive myth out there right now. The idea that, quote, generative AI is just copying and pasting from things it was trained on. And honestly, it is incredibly easy to see why smart people fall for this. When a machine produces a stunning piece of digital art or a flawlessly written Python script in literally 2 seconds, our human brains naturally assume it just ran a giant database query, found a match, and plagiarized it. We kind of assume there must be a massive hidden hard drive full of exact copies. But I'm here to tell you, this is completely false.
What's really fascinating about this architecture is how it actually handles the learning process. Step 1 is indeed studying vast oceans of content, but Step 2 is where the magic really happens. The system doesn't save files. It learns underlying statistical patterns, mapping them into what engineers call a latent space. Imagine a multi-dimensional mathematical landscape. To an AI, a concept like a dog isn't a saved JPEG. It's a specific set of coordinates in a 10,000-dimensional mathematical space, sitting near concepts like fur and ears, and far away from concepts like car or skyscraper. When we reach Step 3, the generation phase, the system navigates that latent space. If it's writing text, it's calculating the mathematical probability of what the next most logical token or word fragment should be. If it's creating an image, it's mathematically predicting how to color the next pixel. It builds new combinations from scratch, probabilistically, every single time. It's complex mathematics, guys, not memory.
Section 4. AI in the real world. Let's talk tools and interaction.
So the absolutely crucial point here is understanding how this shifts our fundamental interaction with computers. For the entire history of computing, bridging the gap between human intent and machine output required highly specialized languages: Python, C++, Java. You had to translate what you wanted into rigid syntax. Generative AI introduces natural language as the new compiler. The prompt, the instruction you give, isn't just a simple command, it's a high-level programming language, where plain English, or any human language, dictates the execution. You set the initial conditions, and the model navigates its latent space to render the brand new output. We have effectively abstracted away the code, allowing human thought to interface directly with algorithmic creation.
And this brilliantly illustrates the incredibly versatile tools we have now. But beneath the surface, they use vastly different architectures. For text generation, tools like ChatGPT and Claude rely on large language models. As we discussed, they're autoregressive. They sequentially predict the next most probable token based on billions of parameters, reading and writing in a linear flow. However, for image generation, think Midjourney or DALL-E, they use a completely different approach called diffusion models. They don't predict the next pixel. Instead, they start with a canvas of complete static, literal visual noise, and systematically remove that noise step by step, guided by the text anchors in your prompt, until a crystal clear image emerges. And now, we're even seeing multimodal orchestration, where platforms like Notebook LM can process source documents and synchronize language models and text-to-speech generators simultaneously to create moving, narrated visual video content.
Now I've got a bit of a meta reveal for you. This very explainer is a direct product of the technology we're analyzing. A foundational text document served as the input. An advanced language model tokenized that text, mathematically mapped the semantic relationships of the core concepts, and traversed its latent space to generate the script. It dynamically structured the narrative arc, optimized the pacing for an advanced audience, and produced the framework of this exact learning experience, token by mathematical token. It literally took the latent rules of educational communication and synthesized them into the reality you're engaging with right now. Pretty wild, right?
We are living through a very rare moment in technological history. Generative AI has definitively shifted the computer from an analytical calculator into a universal synthesizer. The interface is simply your own language, and the engine is a neural network that has mapped the mathematical structure of human creation. Knowing that you now have an instrument capable of rendering almost any concept you can clearly articulate into existence, what's the very first prompt you're going to write? Think about the possibilities of that blank cursor, and I will see you in the next explainer.